Hey, Valerie.
Hey, Bill, how are you?
I'm fine. Let me start my video here.
Okay, cool.
Hey, Sandy. Hey, Steve.
Hi, Valerie. Hi, Bill.
Hello.
So, Bill, once you get your, let's see, I'm going to go ahead and make you the host.
Okay.
Let me, oh, where'd you go? There you are. All right, Bill. All right. All right, I'm going to pin you to the top, and I'm going to make host. Okay, Bill, so you're the host now, so you can mute and you have control now.
Okay. All right.
Awesome.
Okay, well, I'm going to wait a couple of minutes, see if we get some more people on.
Oh, yeah, they're coming in.
Yeah, and then we'll get it
Hey,
started.
Gail.
Okay,
Okay.
I'm trying to find my cell phone.
I don't know what it is.
Oh my gosh. No, I'll see if my iPad works.
Just make sure you don't turn your audio on.
Yeah.
So, Valerie, you started it recording?
Yeah, so it's recording.
Okay, good.
And what I'll do is once it's over, I'll edit it and then I'll send it to you. And then I'll also post it on the website.
Okay. All right, great.
Yeah, we've so far this week, I've had 2 meetings cut off because of the time limit, and it's like, oh,
Yeah.
you know.
Yeah, right, yeah.
So, and then with like Brant, you know, he has a program Thursday. His is like 45 minutes, and then Sal has a program. I said, we just need to get a plan.
Yeah.
So what I'll do is like after this, I'll just send you like I've added you as a user on the account.
Okay.
So you should be getting an email.
Actually, I already did.
Oh, good. Okay, perfect.
Yeah.
Let's see how many we got. We got 11. I've got Brant Ross calling me, so I'm gonna mute myself and step away, but I can see the screen, so I'll be
Okay. Okay, we're gonna wait a minute or two more, see if we get some more people, and then we'll start.
It's not like somebody.
They may can see this.
Yeah. Lower.
Yeah, we're still getting a couple of people coming in, so I'm gonna wait a minute more. Okay, I think we'll go ahead and get started. Okay, tonight is what's called the pink supermoon. And you notice some
You're gonna watch it.
thing here, I said it doesn't look pink to
Shut up,
me.
shut up.
And in fact, it's not going to look pink. So why is it called pink? The reason it's called pink is not because the moon's going to be pink, but it's because it's occurring now in the early spring, and that's when the creeping phlox blooms.
What?
Here's a picture of some creeping phlox, and as you can see, it's pink.
It's possible that you actually have to be a member. I don't know. I didn't think so.
Let's see.
Wait a minute, let me escape
Can
and
you,
look back because there was something else that she had. Okay, wait a minute. Someplace in
okay, so since it's not pink, let's find out about what's super about it. And our picture here shows us what the apparent size of the moon tonight will be as compared to what a normal full moon's apparent size is. So though it's not pink, it is going to be super. It's going to be quite a bit bigger than it would normally appear. That's actually about 30% larger than what we might call a normal full moon. So why does it look bigger? What causes that? Well, we have to look at the orbit of the moon to understand that. Sorry, get right back to it. Okay, I'm going to make this smaller. Okay, we're trying this again. Okay, now where we're going to be. This is a picture of the moon's orbit. And you'll notice that the orbit is, as you might have learned in school, what we call an ellipse. It's not a circle. It's kind of flattened out. And if you look at the position of the Earth, you'll see that the moon is as close as it can ever get to the Earth while it's following this orbit. As it goes around, anywhere else it is, it'll be a little further away. And so that's what makes this a supermoon. Well, let me clarify that a little bit. There actually, in every year, there are 3 supermoons. We already had one. We had one in March. In March, the moon was about right there. So now it's right here, which is, as I said, as close as it can get to the Earth. So this is, in fact, the biggest supermoon of the year. And then in May, it'll come down to this point, and we'll have our 3rd supermoon. So for these 2, they're big, but they're not as big as this one is. So that's what makes the moon look super tonight. It's as close to the Earth as it gets. And so it appears to us to be bigger. Now, unfortunately, you can't quite see. Over here is the sun, and that's illuminating the moon, it's what makes it full. But it might bring a question to your mind if you look at this picture. You might say, wait a minute, it looks like the Earth is between the sun and the moon. And so it looks like maybe, in addition to a supermoon, we ought to see a lunar eclipse. We ought to see the shadow of the Earth passing across the moon. But in fact, that's not correct. And in order to understand why, we need to look at a slightly different picture, which we'll do next. Okay, what this picture shows us is that the moon's orbit is tilted with respect to the Earth. That is, if we look at the rotation axis of the Earth, which runs between the North and the South Pole, it makes an angle of 5 degrees with the orbit of the moon. So as the moon is coming around, sometimes it gets way down here and other times it's way up here. We will only get an eclipse of the moon when in fact the moon is actually right passing over the equatorial plane of the Earth. Otherwise, we just have a normal full moon. Now, I'm just going to give you a little more interesting, well, I think it's interesting. You probably don't, but we'll see. Interesting information about the moon. I don't know how many people knew this. For a short time, earlier this year, we actually had 2 moons. Back in February, a NASA telescope picked up this little thing, which is actually an asteroid. And it's an asteroid that came so close to the Earth that it got captured by the Earth's gravity. And for a short time, that was our second moon. Now, all this other stuff is other objects that were passing through. They focused on this, and therefore the rest of the stuff gets blurred out because it's not in the focus here. So there was our little moon, but when they look at the orbit, they realize that it actually been captured by the Earth's gravity back in 2017. So we really had a second moon for about 3 years. But when they analyzed it, they realized that the orbit was unstable and it would soon be leaving us. And in fact, back on March 7th, it did. It got captured by the sun's gravity again, and it began moving away from the Earth. So let's look at a couple more interesting questions about the moon. Where did it come from and where is it going? Now, it's very interesting because the best answers to both those questions were given to us a long time ago by the Apollo moon missions. We all know that the astronauts brought back a lot of rocks from the moon. And when those rocks were analyzed, it turned out there were two distinct categories. One was rocks that are very similar to moon rocks found commonly, to rocks found commonly on the Earth. That is, they were just basically Earth rocks, but they were on the moon. Now, the other kind of rocks they found, the other kind of rocks they found were really different. They didn't seem similar to Earth rocks at all. But then geologists started looking through collections in natural history museums. And every now and then, they would find a rock that would match up to this different second kind of moon rock. So based on this evidence of the two kinds of rocks and on computer simulations of the early solar system, astronomers believe that the moon resulted from a collision that the Earth had with another planet about the size of Mars. After the collision, the remains of the other planet were captured by the Earth's gravity. And then debris from that collision settled on both the Earth and the moon. So here's a picture of what they think it looked like. Here's the Earth, and here's this other smaller planet comes in and crashes right into it, makes an enormous crash, and then leftover stuff from this other planet forms the moon and gets captured by the Earth's gravity. Then you have all this debris. There's stuff that got broken away from the surface of the Earth, and of course there's stuff from the other planet floating around. So eventually all this material that was knocked away by the crash settles down. Some of it settles down on the Earth, and some settles down on what becomes the moon. So that's how we got some rocks on the moon that are just like Earth rocks. And we got a few rocks down here on Earth, which were like rocks from this other planet that became our moon. Now, when the astronauts came back, they brought back rocks from the moons, but they left something there. They left mirrors lying on the surface of the moon. And these mirrors now allow us to measure precisely the distance from the Earth to the moon. If we aim a laser beam at the mirrors and time how long it takes for reflected light to come back to us, we can measure the exact distance to the moon. That's because we know the speed of light, so we can just multiply it by the time it takes the light to get to the moon and back, and that gives us the round trip distance to the moon. And that's the answer to our other question. Where is the moon going? And the answer is it's going away. In the 50 years since the mirrors were left on the moon, the distance to the moon has gotten about 3 feet further away. Now, this confirms the result that astronomers actually already knew from doing calculations. And that is the moon is gradually getting further away from us. And the reason is because of a thing called tidal friction. And that results from the fact that the moon's orbit is elliptical. When it's closest to the Earth, then its gravity is a little stronger and it slows the Earth down a little bit. And then when that happens, some energy gets transferred from the Earth to the moon, and the moon responds by going slightly faster and getting slightly further away. Now, these are very, very tiny effects. The moon gets about ½ an inch further away each year. And the slowing down of the Earth's rotation adds about 1/500th of a second to the length of the Earth's day every century. So that's not a lot. But astronomers do their calculations, and they say in about 40 billion years, this process is going to cause the Earth and the moon come into what is called double tidal locking. Now, what does that mean? Well, the moon is now tidally locked to the Earth. What that means is we always only see one side of the moon. We never see what's called, it shouldn't be called the dark side of the moon because it's not necessarily dark, but we never see the far side of the moon. When we get to this state of double tidal locking, that means that the Earth's rotation will have slowed down until if you were on the moon, you would always see the same side of Earth. Or, to put it in another way, half the people on the Earth, if there were people in 40 billion years, would never see the moon because they'd be on the wrong side of the Earth. Okay, I think that's it. Let's see. Yeah, okay, I am now going to unmute everybody and let's see if we have questions. Okay, everybody's unmuted. So if you have a question, you can speak up.
Bill,
Yes.
I don't have a question. This is BJ Abraham. It's the first time I tuned in. I just wanted to see if it was working for me. And thank
They
you for
work for you? Okay, great.
Thank you for what you're doing.
Sure.
Yeah.
Okay, anyone else have a question or a comment? If you'd like to say hello, that's fine too.
Okay. Bill, this is Sandy Weisman. I wanted to say hello and thank you. Are we going to see it? Are we going to be able to see the full moon tonight? Or is it?
It's probably, I looked at the weather forecast, it rises about 7:45 tonight.
Okay.
The weather forecast says cloudy, but I would go out and look. I mean, because if you get a break in the clouds, you'll still be able to see it. What you want to do is look due east. It rises almost exactly in the east. And then as time goes on overnight, it starts to move to the southeast.
Okay.
So if you're out right around 8 o'clock, you should be able to see it looking due east. A little later, it'll be a little to your southeast.
Sounds good.
Hi, Bill. It's Victoria. Can you hear me?
Yes, I can.
How are you, Bill?
I'm fine.
Hello to everybody. We're so glad you're here and participating. Thank you, thank you, thank you.
Thank you.
Thank you.
Thanks, Victoria and Bill.
Thanks, Senior Center.
Victoria.
Well, we're just doing our job.